Okay, write the question. Give a heading electromagnetic induction. It's very it's not hard, it's an easy chapter. So it's a mark fetching chapter. Like you can do questions from it. It's not like the question will be too hard. Question won't be hard from you. It's just that you need to know the concepts from this topic. Right? So let's do some standard questions from here. Hmm. Um, Let me find a good question. Okay, before starting, let me revise you this topic a bit. First of all, what was there in this topic? Faraday's law of electromagnetic induction. Okay, so what is Faraday's law of electromagnetic induction? Sorry. See, Faraday's law says that flux of magnetic field through the area bounded by any closed conducting loop. Okay, whenever there is flux, change in magnetic flux. Whenever there is change in magnetic flux, there will be an EMF. EMF is written by this E. Okay, it's minus d phi by dt. Why there is a minus? See, this negative sign it refers to the direction of EMF also, right? For example, this is a loop. This is a bar magnet. Okay, so bar magnet is moving towards the loop. Hmm. It is moving towards the loop, so current will be induced in one direction. Like that is Faraday's law. Faraday's law doesn't give me the direction of current. Which law gives me the direction of current? Which law give me the direction of current? If tell me. Hmm? Which law? It's Lenz's law. Okay. Lenz's law gave me the direction of current, but Faraday's law gives me what? Faraday's law gives me the magnitude. Right. So this is a north pole. This is a south pole. Okay. So the current will be moving in this direction. Suppose if I now take the magnet away from the coil. Okay. If I take the magnet away from the coil, then it will be what? The current direction will be reversed, isn't it? The current direction will be reversed. Okay, the current direction will be reversed. So, uh, that's what the negative sign indicates, right? Okay. So E is equal to minus d phi by dt. Phi is a flux. Flux means suppose this is a magnet coming towards it. So these are the flux. This is the electric flux. Okay, this is the electric flux passing through the coil. Electric flux passing through the coil. All right. So uh, so this EMF is what? Change in electric flux, like change in magnetic flux. So if the magnet is moving towards the coil, if it is at rest suppose, then the number of flux is what? Number of field lines is constant, right? Number of field lines is constant. But suppose I am moving it. So if I am moving it, then what happens? Then the number of field lines is changing every minute or every second, whatever. Okay, like this at this position it will be like this, so it's changing. Okay, so because of that change EMF is induced. EMF means what? EMF is equivalent to voltage. If you don't understand EMF, no need to worry, it's kind of voltage. If I suppose connect it to a wire or circuit, it will be what? It will be a voltage. Is that all right? Is that all right? Hmm? Okay. So if okay, so this is your basically your EMF, which is your minus d5 by dt. What is a flux? What is another formula for flux? Another formula for flux is B dot ds. Okay, B dot ds. Your B dot ds is what? Flux is equal to B dot ds. B is your what? Magnetic field. B is your magnetic field, and ds is your area. Okay, area element. Suppose this is a some surface. This is your flux. This is a magnetic field. So how much magnetic field lines are passed through this any area element? Suppose this is the area element ds. So that is called what? That is called flux. All right. So flux is equal to B dot ds. So I can put this B dot ds here also. So E will be EMF is equal to minus d by dt of integration B dot ds. I can write this also. Is that all right? Now tell me what is current? What is current? Current is your simply what? Current is your simply current is your simply V voltage by resistance. Current is just simply voltage by resistance. Is that all right? So voltage is what EMF? EMF by R. EMF is how much? Minus d5 by dt. And this is a R into 1 by R. Okay. Is that all right? Okay. So this is your formula for current. I is equal to minus 1 by R d5 by dt. Is that all right? Okay. This is a Faraday's law of electromagnetic induction. Now, what is your Lenz law? What is your Lenz law? Lenz law tell me the direction. Suppose this is the way, this is the magnet, this is a loop. If the loop is going towards the, if the magnet is going towards the loop, then it is what? What it will it will the current will be such that it will oppose the motion of the magnet. So if north pole is moving, then it will create north pole only, which will oppose the current, which will oppose the magnet. Okay, because this north pole is there, this north pole is there, so it will oppose the movement of the magnet. Suppose the magnet is moving away, suppose the magnet is moving away from it, then how this loop can produce something here so that it will oppose the motion? Oppose the motion means it will not go away, it will attract it, it will create south pole. If it creates south pole, then only it can attract the magnet. Okay, got it? So this is a which current? Anti-clockwise. This is anti-clockwise, and this is a clockwise. Is that all right? This is anti-clockwise, this is a clockwise. Okay, yeah. So this is your what? Lenz law. I hope you can understand. Okay, next is what? Motional EMF. Motional EMF. What is motional EMF? Due to the motion of a conductor, okay, EMF will be produced inside a magnetic field. There is motion of the conductor. So EMF is E is equal to BVL. Okay, E is equal to what? BVL. All right. Is it clear? Next is self-inductance. The self-inductance relation of phi is equal to Li. This is your L is equal to phi by I. This is the formula for self-inductance. Self-inductance means suppose this is a coil. Okay. So if current flows through this like magnetic for there is change in magnetic flux through this coil, then current will be induced in it itself. All right. So L is equal to 5 by I. So E is equal to minus L d phi by dt. Okay. Sorry. Di by dt. I'm sorry. Minus L di by dt. These are all right. Now self inductance of a long solenoid. Okay. So flux is equal to how much? BDS. It can be a derivation kind of question, 2 marks or something. BDS. Okay. Now tell me what is the magnetic field for a long solenoid? B is equal to mu naught Ni, right? Yeah. So mu naught Ni. What is the area? Pi r square. Mu naught Ni pi r square. Now EMF induced is how much? EMF induced minus del phi by del t minus del by del t of mu naught Ni pi r square. Okay. So this is mu naught n pi r square del by del t of I. Hmm. Okay, so this term is actually your what? Okay, we know what? We know EMF is what? Minus L d by dt. So if you compare these two equations, 1 and 2, what will you get? If you compare this, we'll get L is equal to mu naught n, n pi r square. Okay, mu naught n pi r square. So from here we can conclude that L depends on what? R, isn't it? Also L depends on n. Actually, what is small n? Can you tell me what is small n? It is actually n by L, number of turns per unit length. Okay? Number of turns per unit length. Okay. So now see, so your L formula is how much then? Mu naught n pi r square. Okay. So there are wait. This is for one turn only. Suppose there will be n turns. Okay. So for one turn it is this one for one turn. Suppose n turns. N means what again? N by L is equal to small n. N is equal to n L. So just put it here. Sorry. Right. N is equal to N L. So for n turns, L is equal to n into L total is equal to n into L. So NL into mu naught n pi r square mu naught n square pi r square. Okay. So this is your self inductance for a long solenoid. Okay. Is that all right? Okay. Next, just write a formula. There is, for example, there is growth and decay of current in an LR circuit. Okay. So just write down growth of current in LR circuit. So I will be E by R 1 minus e to the power minus IRT, minus RT by R. Write a question. An inductor L is equal to 20 millihenry. A resistor R is equal to 100 ohm, and a battery is equal to 10 volt are connected in series. Find the time constant. The maximum current. The time elapsed before the current reaches 99% of the of the maximum value. Is that all right? An inductor, a resistor, and a battery are connected in series. Find the time constant, the maximum current, the time elapsed before the current reaches 95% of its maximum. Please try the question for 2 minutes. You have 2 minutes. Please try the question. Please try. If you don't try, then you won't be able to solve it in exam. If I solve everything, then you won't be able to solve it. See, which kind of circuit is it? LR circuit. Okay. Okay, first of all, what is time constant? See, time constant tau is equal to L by R. Okay, that is 20 millihenry divided by what is R? How much is R given? 100 ohm. Okay, 100 ohm. So that gives me 20 by 100. That means 1 by 5. 10 to the minus 3. Right? What is the unit of tau? Of course, it will be second because it's time constant second. This is 0.2. 10 to the minus 3 second. That is 0.2 millisecond. Alright? Now the question is maximum current. What is the maximum current? Maximum current I is equal to how much? Simply E by R. Okay, E by R. What is E? E is your 10 volt. R is how much? R is your 100 ohms. So that gives me 0.1 ampere. Right? What is the unit of current? Ampere. Now see, the time elapsed before the current reaches 99% of the maximum value. So what kind of formula will be used here? See, we will use I is equal to I naught 1 minus e to the minus t by tau. So I is what is given in the question. It will reach 99% of the maximum value. That means what? Maximum value we know is I naught. 99% of its maximum value. That means 99 by 100 percentage. I naught is equal to I naught 1 minus of the part minus t by tau. So I naught will be cancelled out. 99 by 100 is equal to 1 minus e to the minus t by tau. So I will take this 1 to this side is equal to minus. So this will be minus 1 by 100 is equal to minus e to the minus t by tau. So that will be 1 by 100 is equal to e to the minus t by tau. So take the e to the other side, it will become ln, right? Minus t by tau. So if I take the minus ln 100 is equal to t by tau. Ln 100 is how much? Ln 100. Okay, tau we got right. Yeah, tau we got as 0.2 milliseconds, so we can put it here. 0.2 into 10 to minus 3 into ln 100 is equal to t. So if you use a calculator now, so this will give me 0.92 milliseconds. ln 100 will be given, don't worry. It will be given in the question, okay? These things we don't know now, so it will be given in the question. See, this formula is being used for growth of current. Growth of current. We had discussed before growth of charge, decay of charge. So growth of current, we are using this formula. Again, let's. So what will be the formula for decay of current? Decay of current. I is equal to I naught. Direct. This is decay. Growth is that all right? Is it is it okay? Is it okay? See, it's not that hard. It's just a bit like calculations are there. You just have to be careful about the calculations. Otherwise, it's not hard. You write one question on the decay of current. This was a question number one. Question number two. An inductor L is equal to 20 millihenry. A resistor R is equal to 100 ohm, and a battery E is equal to 10 volt are connected in series. Okay. After a long time, after a long time, what happens? The circuit is short circuited. The circuit is short circuited. What is short circuit? Hmm? And the battery is and the battery is disconnected. Right? Find the find the current. Okay, in the circuit 1 millisecond after short circuiting. Read the question first two times. Read the question two times. The third time write the data and fourth time solve. Two times read the question. What is the initial current here? How to know the initial current? Hmm? How to know the initial current? Simple. Initial current I naught is equal to how much? E by R. This much only. 10 by 100 ohm. 10 by 100. That is 0.1 ampere. Okay. Now what is time constant? Why I am calculating time constant? Can you tell me? Why I am calculating this? This way though I can calculate everything. But why time constant? Because we need it. Battery is disconnected. That means what? There will be a decay of current. See, I am telling now that this is a question of decay of current. Then, like, but in the exam, how will you know that this is a question of decay of current? From the terms that is given in the question. That is, the circuit is short circuited. When the circuit is short circuited, it's obvious that the current will decrease. If the current is decreased, that means it's called decay of current. So if decay of current is there, what is the formula we know? We know the formula is I is equal to I naught e to the power minus t by tau, isn't it? Right? This is for decay. So we need tau for this, isn't it? We need tau. Tau is what? L by R. We know L by R is tau. So just put it L by R because this is a LR circuit. So 20 millihenry divided by divided by 100 ohm. Alright? That will give me 0.2 in 10 to the minus 3 seconds, isn't it? Okay, now it's simple. Now you just need to find the current. What is the question? Find the current in the circuit 1 millisecond after short circuiting. So what is my one I is equal to I naught e to the power minus t by tau. Is it all right? So current I will be I naught is how much? 0.1 e to the power minus t. T is what? 1 millisecond, right? So 10 to the minus 3 divided by What is tau? Tau is just for 0.2 millisecond. 0.2 10 minus 3. Alright. So 0.1 into e to the power minus, this will be 10 by 2. 0.1 into e to the power minus 5. See, e to the power minus 5, we don't know the value, right? If the value is not given in the options, then we can just leave it like that. No problem. Otherwise, if it is given in the like in the question, then just direct put the value. The value is okay. Just leave it like this. Okay. The value is not given in the question, so just leave it like this. No problem. You will get the full marks, 2 marks. Okay. You will get the full 2 marks. Is that all right? Is it all right? Okay. Now I will move to the next question. Okay. Question number 3. A conducting circular loop of face area. Hmm? Yeah. Face area 2.5 and 10 to the power minus 3 meters square is, it's a bit longer, placed perpendicular to a magnetic field which varies as which varies which varies as, how does it vary? B is equal to 0.2 Tesla, okay, sine 50 pi second inverse t. Why I have written Tesla and second inverse here inside? Because Tesla is for magnetic field, second inverse is for time. It's the it's the way of writing. Okay, don't be confused by this. Find the charge. Find the charge flowing flowing through any cross section. Through any cross section. Okay, during the time during the time t is equal to 0 to t is equal to 40 millisecond. If the resistance of the loop is 10 ohm, find the thermal energy. Find the thermal energy developed in the loop developed in the loop in this period. In this period. This is the question. Please read the question 3 times. Take as much time as you want, but do this question yourself, please. First, read the question 3 times, then write the data that is given, then analyze it a bit, how to solve it. Don't just depend on someone to solve your questions. Start solving them yourself. Otherwise, if the question, suppose, see, question may be easy or question may be hard in the exam. Suppose the question is hard. So, according to that, we have to prepare, right? We have to prepare for a harder question so that we'll do good in a easier question. But if you only prepare for an easy question, then if it comes hard, then gone, right? All our hard work will just go away. Just try this question. Okay, first write down the data that is given. All right. Tell me what is the data that if area is given A is equal to 2.5 into 10 to the minus 3 meters square, then your magnetic field changes. How is it? How does it change? We know magnetic field changes. B is equal to B naught sine omega t. Okay. So here B is equal to 0.2 Tesla. Omega is equal to 50 pi. Hmm. R is equal to how much? 10 ohm. So flux through the loop at time t phi is equal to B naught A sine omega t. Hmm. EMF will be how much? Minus del phi by del t. So minus del by del t of B naught A sine omega t. Okay. Now B naught A will come out del by del t of sine omega t. Okay. Now minus B naught A omega cos omega t. Hmm. Now your current will be E by R. So minus B naught A omega by R cos omega t. So this is your actually I naught. So I naught cos omega t minus I naught. Sorry. Current here current changes sinusoidally, right? So T is equal to 2 pi by omega. 2 pi by omega is how much? 50 pi. So 1 by 25. Okay. Which is actually how much? 0.04. Yeah, 0.04 second. Hmm. Now what is the question? Find the charge flowing through any cross section from time to. We know what? We know current is dq by dt. Charge is how much? I dt. If I integrate both sides, dq. Q is equal to I dt. What is the time? T is equal to 0 to 40 millisecond. Okay. What is I? I naught sin omega t is 0 to 40. Omega t dt. Sorry. Minus cos. My bad. Minus I naught Integration of cos omega t is sin omega t by omega 0 to 40. Okay. See, let me write it as capital T only, okay? Time period. So minus I naught by omega sin omega t. What is t? T is your 2 pi by t. 2 pi by omega. So omega by cancel. Sin 2 pi is how much? 0. So your q is actually 0. Your q is actually 0. Now what is the question? Next question. If resistance of the loop is 10 ohm, find the thermal energy developed in the loop. So thermal energy. What is the thermal energy? H is equal to I square R dt 0 to t. Hmm. So I naught square R dt 0 to t. Sorry, I square is how much? I naught square cos square omega t R dt 0 to t. I naught square R. What is cos square omega t? Can you tell me? How can I write cos square omega t? 1 minus, sorry, 1 plus cos 2 omega t by 2. Put it then. I naught square R 1 plus cos 2 omega t whole divided by 2 integration 0 to t dt. I naught square R, this is t by 2 plus sin omega t by 2 omega, 2 is there, 0. I naught square R, this is t by 2 plus sin omega t by 2 omega minus 0 0. Omega is we know 2 pi by omega, right? So I naught square by I naught square 2 pi by omega 2 omega sin omega 2 pi by omega by 2 omega. Sin 2 pi is 0, we know. Just put it there. So now see, 2 to cancel. I naught square R pi by omega. Okay. Is that alright? Okay, now I naught is how much? I naught is this one. If you remember, I naught is B naught A omega by R. So just put it there. B naught A omega by R whole square. Okay. Now you just have to simplify it. Put the values, you will get the answer. Put the values and get the answer and tell me how much you're getting. How much you're getting. Put all the values. Put all the values. If you put all the values, you will get the answer as 1.25 10 to the minus 5 joule. Okay. Please check. Please check. Please check till then. I will write the next question. This will be a question number. How much? 4, right? Yeah. 4. Question number 4. long solenoid. The coil is connected to a galvanometer as shown in the figure. If the current is if the current in the solenoid is changed from 5 ampere in one direction to 5 ampere in opposite direction, find the charge find the charge which flows through the galvanometer. Yeah. Long solenoid of radius 2 centimeter has 100 turns per centimeter and surrounded by a 100-ton coil of radius 4 centimeter, having a total resistance of 20 ohm. The coil is connected to a galvanometer as shown in the figure. If the current in the solenoid is changed from 5 ampere in one direction to 5 ampere in opposite direction, write the charge which flows through the galvanometer. Please try this question. Please try this question. Please take your time. Read it 3 times. Read the question 3 times. All right. So see, uh, solenoid has radius is given number of turns per centimeter surrounded by 100 turn other radiuses. Okay. Find the charge which flows through the galvanometer. I hope you have read the question. Okay. Induced EMF will through the galvanometer will have d phi by dt will be equal to how much? Hmm? D by dt of NBA because number of turns is n. dA. N goes out. Yeah. A also goes out. dV by dt because there is a change in magnetic field. So n into pi r square dV by dt. Hmm. Now you tell me through a solenoid what is the magnetic field? Mu naught Ni, right? Mu naught Ni. So d phi by dt is equal to d phi by dt is equal to n pi r square d by dt of mu naught Ni. Okay. So n pi r square mu naught n di by dt. Okay. So now if r is the resistance of the coil, so your current to the galvanometer will be what? Ig, suppose. Ig is equal to pi r square. This one, pi, like the flux, hmm, pi r square n. Flux means what? Your EMF, isn't it? So current will be what? E by r. Hmm. So this by r, n mu naught n di by dt whole divided by r. Okay. So your I will take this dt to this side. So Ig dt mu naught, sorry, okay, mu naught n pi r square n df dl by r. Okay, is that all right? Now total charge, if we have like total charge is asked, total charge passed through the galvanometer. So Q is equal to, we know, integration of I dt. Okay, integration of mu naught n pi r square n by r dt. Okay, okay, sorry, I'm sorry, di. So pi mu naught n pi r square n by r. Right. Yeah. So now again, just everything is there. You just have to put the values. All right. You just have to put the values. Please put the values. I did the whole derivation. You just have to put the values. That's it. I'm not gonna do that for you also. Please put the values and let me know the answer. Okay. You will get the answer as 100 microcoulomb. This is the answer. Okay. Yeah. Okay. Write a homework. Write a homework. There will be question number 5, I think. Question number 5. Figure shows a square loop having having 100 turns, an area of 2.5 into 10 to the minus 3 meters square, and a resistance of 100 ohm. The magnetic field has a magnitude of B is equal to 0.4 Tesla. Find the work done. Find the work done in pulling the loop out, in pulling the loop out of the field slowly and uniformly in 1 second. Okay, so homework. Okay, write it down. Figure shows a square loop having 100 turns, an area of 2.5 10 to minus 3 meters square, resistance of 100 ohm. The magnetic field has a magnitude of B is equal to 0.4 Tesla. Find the work done in pulling the loop out of the field slowly and uniformly in 1 second. Okay, write it down first. So these were some of the questions we did today. I hope you understood. It's very good questions, standard, good questions that will clear a lot of concepts of it. Okay, and these questions may also come in entrance exams. Okay, like JEE mains and all. So I hope it helps you. Hmm? And please keep practicing. Please try to do questions yourself. Okay, don't just rely on anyone to solve it for you. Please try to do yourself, and that will really help you. Right? Don't just copy the answers. Okay. I hope this video helped you, and yeah, thank you very much. Please let me know if you have any doubts. It's a good questions. Okay, thank you very much.